Okay, so hopefully what you wrote down, for very simple reasons, is the integral from 0 to pi over 2, because that's what the integral we partitioned. That's what goes from I equals 1 to n, right? It's just going to be lambda of x, y. Well, actually, we're going to want it all to be in terms of t, right? So it's going to be lambda of x of ti, which is what? R cosine of t, R sine of t. Now what's the square root of, what's x prime of ti star? I haven't written the intermediate steps here because I'm just kind of skipping, but I want you to think through that. Well, x is r cosine theta, right? Or r cosine t. So it's negative r sine t, right? Well, this is just going to be let myself more room. It's going to be square root of r squared sine squared t plus r squared cosine squared t. Just taking those derivatives, very straightforward, and you understand motion along a curve.
That's just r, right?
Yeah. Yeah, well, from there you do the integral, right?
Well, can't you simplify the what's under the square root to just r squared?
Well, part of doing the integral is simplify whatever's in here first, right? So from here you do a little algebra and you do the integral. And remember, r is just a constant, right? And maybe I should have written it as a capital R, because every time you write it, you're thinking polar coordinates. Okay? So maybe I should have made it an A or something. But sometimes it's going to be an R. Okay? So, okay, and we still don't know what lambda is. We can't really write out the whole thing in this case, right? So I'm just going to write what's in here. Okay? So we could do a lambda. Now, in general, be aware that it's not going to necessarily simplify as nicely as this does, but a lot of your examples will simplify pretty nicely. Okay? You don't want a very complicated expression under here. If you're trying to integrate over an ellipse, it gets pretty complicated because you can't do this simplification, and your integrals get a little more involved. Okay?